Welcome back for part 2 of discounts. This one's going to work a little different. Sandy has a 25% coupon for athletic equipment. She buys hockey equipment for the final price of $172.50. And we want to know, what is the original price going to be? What are we actually looking for here? Are we looking for the part, the percent, or the whole? We're actually looking for the whole here, folks. This is a percent change problem, but we're not looking for the amount of change. We're not looking for the percent of change. We're not looking for the new amount. We're looking for the original amount. This is going to be interesting. So to start off with, they set up the problem. They said that if the amount of discount is 25%, then the sale price was 100% minus 25%. That means 75%. So you're still paying 75% of the original price. And we know that 75% of the original price was $172.50. If you look at the proportion they've given us, it looks very similar to what we've worked with before. You have the 75%, that's what you paid, 75 over 100. But then if you look right here, we had been putting the original price in the bottom. We're not doing that. We're looking for the original price. The sale price is what goes on the top. After that, everything else is going to work very similar to what we have been doing in the past. Now, they used some strange voodoo math on this one. They said, yeah, everybody knows that 75 times 2.3 is going to equal to 172.5. Where on earth did that come from? Let's pause the recording and let me change screens so I'll show you. So instead of doing what they did, where they said 75% of what number equaled 172, I'm going to go the other direction. I'm going to say 172.5 divided by the 75 is going to give me what number? And I'm going to use my calculator because I'm just being nice to y'all in this chapter. 172.5 divided by 75, that's where the 2.3 came from, 2.3. So now you can say, well, 75 times 2.3 is going to be 172.5. So what is 100 times 2.3 going to equal to? That part's easy. That's going to be 230. So the original price is going to be $230. And you can see that's what they did here. They multiplied 100 times the 2.3, and when they did, it gave them the $230. So the original price before any discounts of the hockey equipment was $230. Check your answer. The answer works. We got a pretty good think about it question on this one. When writing the proportion, why did we use 75% instead of 100%? Well, if you went back and looked at the problem, 25% was the saving. It was a discount. But the amount of money paid was 75% of the original price. That's the reason we use 75%, because $172.50 was 75% of the original price. Alright folks, now it's your turn again. Pause the recording and find out which one of those four numbers is going to be the original price on this tablet. Did you get the right answer? Let's see what I do. I start off by finding out, well, if we're saving, if the sale is 30% off, that means we're still paying 100% minus 30% is going to equal to 70%. That is how much money is still being paid. So with that, we can set up our proportion. The sale price now goes on top, $239.89 over the original price, and we're going to call that just P, is equal to, well, what we still paid was 70% of the 100. Now we're going to have to do some of that other math over here, and I'm going to let you use your calculators because, guys, these numbers are not fun. $239.89 divided by 70 is going to equal to, and when I do that, I get 239.89 divided by 70, and we're going to find that that rounds out to be, wow, what a number, 3.427. Now we have to take that number and multiply it times 100, 3.427 times 100, which means that you're going to end up with, come down a little bit so we have room, $342.70. That would have been the original price of the item, $342.70. Let's see if that is a choice that they gave us here. $342.70. Check our answer, and it checked well. And now you know what we have left to do? That's right. All that's left is the apply problem to make you flex those brain muscles and really think about what's coming next. So our apply problem wants to know what are some real-world problems involving discounts. And they say, watch the animation and find out. Well, this should be fun. Here we go.
The Wares want to buy a new computer. Store A has a regular price of $1,300 and is offering a discount of 20%. Store B has a regular price of $1,089 with no discount. If there is a 7 1/4% sales tax in their city, at which store should they buy their computer? How much money will they save if they buy at that store instead of the other store?
Well, that's a pretty interesting question. Let's dig into this just a little bit. Remember, they want you to read your question 3 times. Remember, they want you to be able to write in words how you're going to solve the problem. And then they want you to be able to take and come up with solutions. And I believe they want 2 answers. First one, where should they buy the computer? Second one, how much money will they save if they buy the computer there? And finally, you need to be able to defend your question. Now, I do want to say be careful about something, because let me reread it again. Hold on. Yep, they have themselves a real-life, honest-to-goodness distractor right here with this 7.5% statement. You see, 7.5% does not get involved in a sale or a discount traditionally. Now, I'm not sure if they were going to try and do that to us here, but I'm going to tell you right now, kick that out in the garbage. That has no bearing on the real life of this problem. Did they use it in this one? Maybe. We'll find out when we check our answers. But I'm thinking that that doesn't belong in the problem at all, and all you need to do is find out which store is going to give you the better deal and by how much you're going to save. Actually, hold on. There is a place for that 7.5%. And that's going to be where you got to find the tax on the final purchase price, and then that will be a little bit different. So you do need to use that, or 7.25%, you do need to use that before you can get to your final answer. Good luck. So was it store A or was it store B? Who had the better deal? Let's find out. Now, I went ahead and highlighted the 2 questions, one in blue and one in pink, to help me keep focused on what the questions are actually asking for. And now I'm going to take and start off with store A. And in store A, I want to find out what the regular price or the sale price of the computer is going to be. So I'm going to set up my proportion. Sale price over $1,300 is equal to, the discount is going to be 20%, and if you're saving 20%, how much are you paying? 80% over 100. I'm going to say to myself, all right, let's get a little spacer here. 100 times what number is going to be whoops, I'm sorry, I put that in the wrong spot. It's going to be 1,300, and the answer to that is going to be 13. 100 times 13 is 1,300. I have to do the same thing with my 80. 80 times 13. And when we do that one, we get 80 times 13 is going to be $1,040. $1,040. Now we know that store B is going to be $1,089 with no discount. So right off the bat, who's going to have the better price? The better price is going to be store A. So store A had a sale price of $1,040, which was less than store B's. But that really doesn't do us a whole lot of good at this point. That only answers the first part of the question, which we can go ahead and put in here right now, that which one's going to have the better deal. Well, the better deal is going to be store A. But we still need to find out how much money we're going to save. And to find that out, we're going to have to incorporate some sales tax, and that's where things are going to get really exciting. So to find my taxes that I'm going to pay on the $1,040, I'm going to set up another proportion that says tax over $1,040 is equal to, well, 7 1/4 is the same thing as saying 7.25 out of 100. We can ask ourselves, 100 times what number is going to equal to 1,040, and the answer to that is going to be, let's see, 10.4. And if I multiply the bottom by it, I have to multiply the top by it. 7.25 times the same 10.4. Grab our calculator here. 7.25 times 10.4, and that's going to give us a tax rate of $75.40. But that's not the final selling price. To get to this final selling price, I now have to take and add the $1,040 that the computer costs after the discount and the $75.40. And when we do that, we're going to get, let's see here, that will give us, I'm thinking if I'm doing the math right in my head, $1,115.40, but let's go ahead and double check my numbers there. So 75 plus 1,040 equals $1,150.40. Very good. So that is the price out the door of the computer from store A. Now we want to take and find the price out the door for the computer from store B, and that's going to be set up the same way. Tax over, this time store B was $1,089, is equal to the same 7.25 over 100. I'm going to say to myself that 100 times what number equals 1,089, and the answer to that is going to be 10.89. If I do it on the bottom, I have to do it on the top. 7.25 times the same 10.89 is going to give us the tax amount. Grab our handy dandy calculator here. 7.25 times 10.89. And with that, we're going to find that the tax on this one, rounded to the nearest penny, is going to be $78.95, which we have to add back to the original price here, or the selling price. So we're going to take the $1,089, add to that $78.95, and when we do, we're going to get 1,089 plus 78.95 equals $1,167.95. So we're going to do 1,000, where was it? $167.95. But that still doesn't get us to where we need to go. Last step, we need to find the difference between them. So I'm going to take the $1,167.95, subtract from it the other price, $1,115.40, and when we subtract those over, we're going to get a 5, a 5, we're going to get a 2, a 5. We're looking at a difference of $52.55. Let's see if we are right. $52.55. Check our answer. Woohoo! We did it all without a single mistake. That's always encouraging. This, guys, is showing your work. A lot of supporting work there, wasn't it? You can do it, though. Don't give up. Work hard. Most of the problems on your homework are not going to be this ugly. Do the best you can. I look forward to seeing what you come up with.